Welcome to homework.
We're asked to find components of the force acting along cable BA, and we're given these dimensions here in blue, which act as the coordinates for point A and point B. First thing we want to do is we want to find the position vector for this force acting along BA, but let's write down coordinates for A. So A will be our well, it's actually going to be our x2, y2, and z2, and that's going to be equal to 0, 480, and 0, and that happens to also equal the position vector from O to A, from the origin to A. And then point B will be our x1, y1, z1, and that's going to be equal to negative 320, 0, 360, and that's going to be our position vector from the origin to B. So if we want our position vector from B to A, well, that's equal to our position vector from the origin to A minus the position vector from the origin to B. And then we get 320 in the x plus 480 in the y minus 360 in the k, and this is millimeters. And we'll also need our magnitude of our position vector. That's equal to the square root of the x component squared plus the y component squared plus the z component squared. That's equal to, get better equals than that, that's equal to 680, and that's also millimeters. So to calculate the components of our force along BA, we can just say that the force along BA is equal to the tension we're given in BA times our unit vector of BA. Well, that's equal to tension in BA. Actually, you know what? I'm just going to write that out. The tension in BA we're given is 408 newtons times our position vector, 480J minus 360K over the magnitude of our position vector, because this here is equal to the unit vector. And when we multiply all this through, we get that the force along BA is going to be equal to 192 in the x plus 288 in the y minus 216 in the z. These are all in newtons. So our x component is 192, our y component is 288, and our z component is negative 216.